Imagine a notebook so dangerous it lives in a lead-lined box. Whose notes could glow with history like that? Marie Curie's. Today, we race through the true story of the first person to win 2 Nobel Prizes in 2 different sciences, and the surprising ways her work saved lives. Born Maria Skłodowska in Russian-ruled Warsaw, she grew up among microscopes and magnets from her father's physics cabinet. As a teen, she snuck into the secret Flying University, where banned Polish students learned in private apartments. Curiosity wasn't a hobby, it was her rebellion. Money stood in the way of Paris, so Marie worked years as a governess, sending her wages to help her sister study medicine, promising that one day they'd trade places. Between tutoring sessions, she taught herself math and chemistry from tattered textbooks and home-built experiments. Finally, in Paris, she studied at the Sorbonne by day and shivered in a tiny attic by night, sipping hot tea to stay warm. Her grades shot to the top. Then she met a quiet physicist, Pierre Curie, whose precision instruments would become the key to her discoveries. They married simply. No veil, no fuss, just a dark blue dress Marie could wear in the lab. Their honeymoon? Second-hand bicycles and open roads across the French countryside. It was a partnership of minds and miles. Using Pierre's super-sensitive electrometer, Marie measured invisible rays from uranium salts. She found something bold. The strength of the rays didn't depend on a compound. It came from the atoms themselves. She gave that phenomenon a new name: radioactivity. Testing a mineral called pitchblende, she saw readings far stronger than pure uranium. The numbers were so high, they hinted at hidden elements no one had isolated. If the math was right, the periodic table wasn't finished. Paris gave them a drafty wooden shed, part lab, part kitchen. Huge iron cauldrons simmered crushed ore in acid. Marie stirred for hours, hauling buckets, crystallizing and recrystallizing. Winter leaked through the roof. In summer, the shed steamed like a bathhouse. It took tons of rock to get pinhead specks of something new. First came polonium, named for her homeland, Poland. Then radium, whose salts made special screens flash with an eerie blue-green light. It wasn't magic, it was matter reshaping science. The world rushed in, doctors, entrepreneurs, and the curious, eager to harness the strange energy. In 1903, the Curies shared the Nobel Prize in Physics. 3 years later, Pierre died in a street accident. Marie took his chair at the Sorbonne, becoming its first woman professor. She pressed on, isolating pure metallic radium, and in 1911 earned a second Nobel, this time in chemistry. Fame brought offers to patent her radium process. She refused. Radium, she believed, should be available to all researchers. It was an unusual stance even then, and it accelerated discoveries far beyond her own lab. When World War I erupted, Marie rushed not to a podium, but to the front. She outfitted cars with X-ray equipment, petites Curies, and learned to drive and repair them herself. She trained over 100 women as radiology aides. Surgeons could finally see bullets and shrapnel before cutting. Thousands of soldiers owed their limbs and lives to clear images. After the war, American journalist Marie Maloney organized a nationwide fundraiser. The gift? 1 gram of radium for Curie's research. In 1921, President Warren Harding presented it to her at the White House. When asked what jewel she wanted, Curie had once replied, radium. People loved the story that a flask of radium glowed softly on Curie's desk. There's truth and myth tangled there. Radium can make certain screens glow, and many early lab materials became contaminated. We now know that radiation can be dangerous. Curie herself developed aplastic anemia, and her lab notebooks are still radioactive today, handled in protective boxes. The Institut du Radium grew under her direction. Her daughter Irene would win a Nobel too for creating new radioactive elements. In 1995, Marie and Pierre were reinterred in France's Pantheon. Marie, the first woman honored there for her own achievements. From cancer therapies to everyday X-rays, her legacy is everywhere. Here's the twist. The most immediate lives she saved weren't from radium at all, but from those rolling X-ray rooms in a war zone. Curiosity led her to atoms. Responsibility drove her to action. If one scientist could change both science and medicine, whose story should we race through next?